Hello students, this session we are going to discuss with the VSEPR theory. The expansion for VSEPR theory is valence, shell, electron, pair, repulsion theory. This theory is proposed by Sedgwick, and Powell in 1940. And VSEPR theory, it is a part of the chemical bonding. Means under the chemical bonding there are various theories they have put forth in order to explain the bonding nature in molecules. When we are talking about the timeline, just I am brush upping the timeline. First, in 1916, Lewis and Cosell, they proposed the theory of chemical bonding, and somewhat it is acceptable, and it has some demerits also. Later in 1919, Langmuir who proposed the theory of covalent bond, and this theory of covalent bond, it is the sum of the modifications done to the Lewis theory, hence it is called as covalent bond theory or Lewis Langmuir theory. After this, in 1927, Hitler and London they proposed the valence bond theory. Then after this, in 1932, Friedrich Hund and R.S. Mulliken they proposed the molecular orbital theory. And this molecular orbital theory, it is a widely acceptable theory, and we can say it is an at most advanced or molecular orbital theory. Okay. In 1940, Sedgwick and Powell they proposed the valence shell electron repulsion theory. And we have to know this, each theory has its own merits and demerits. In valence shell electron pair theory, this session we are going to discuss what are the postulates of VSEPR theory and how it is possible to say the structure and the hybridization of the molecule using this theory. The timeline and the other theories we are going to discuss in our other videos. Okay. The main postulates of the VSEPR theory are here. The first theory is the shape of the molecules. This depends on the number of valence shell electron pairs. It may be bonded or non-bonded around a central metal atom. Okay. Let us consider an atom or a molecule which has its own number of valence shell electrons. Okay, which may be bonded or which may be non-bonded. Okay. Suppose consider a carbon atom. Okay. 1s2, 2s2 and 2p2. Okay, so this 1s, it is the inner shell, and it is 2s 2p2, they are also called as outermost shell, or it is also called as valence shell. In this valence shell, the 2s orbital containing 2 electrons and the 2p orbitals containing 2 electrons. Okay, so the electrons, it may be bonded or it may be non-bonded electrons, and these non-bonded electrons, they are going to make a bond with the neighboring atom. Okay, so then second postulate is the pair of electrons involved in the valence shell repel each other since their electron clouds are negatively charged. The pair of electrons means it may be bonded electron or it may be non-bonded electron. Let us consider a simple example, methane. It has only bonded pair of electrons. It don't have any lone pair of electrons. Whether it may be, or take one more example of ammonia. It has both bond pair electron and lone pair of electrons. Lone pair of electrons means they are not at all involved in the bonding. They are remaining on the atom itself. That is why we call this one as lone pair of electrons. This is lone pair of electrons, and nitrogen and the hydrogen, which makes a bond, covalent bond, you call this one as bond pair of electrons. Okay, these pair of electrons, they are always repulsive in nature. Why they are repulsive? The repulsive nature are because the electron clouds are negatively charged. Okay, either it may be bonded electron or non-bonded electrons, they are always repulsive in nature. Okay, because of the third postulate is, because of these electron pairs are repulsive in nature, they are tend to occupy in the space with maximum distance and with minimum repulsion. Means, suppose assume carbon and hydrogen. Okay, here the bond angle. Okay, bond angle is 109 degree 28 minutes. The bond pair repulsion is taking place here because these two bonded electrons, they are made up of electron clouds. In order to minimize the repulsion, in the space they are going to orient itself in space so that it can occupy a particular position, and this is going to give a particular shape of a molecule. Okay, so later on we can discuss the what are the different types of repulsion that is going to occur in the molecules. Then the fourth postulate, the valence shell is taken as a sphere with the electron pairs localizing on the spherical surface at maximum distance from one another. Means here simply we are considering the central atom as a sphere, and these electron clouds or electron pairs, they are delocalizing and they are maintaining the maximum distance in order to minimize the repulsion. They are going to give you a particular shape of the molecule. That is the meaning of this fourth postulate. And fifth postulate is a multiple bond is treated as a single bond if it is a single electron pair and two or more electron pairs of a multiple bond are treated as a single super pair. Means suppose if you take an carbonate CO3 2 minus, here the carbon is attached to three oxygen bond by means of a double bond. Here we have to consider this double bond, C double bond O, C double bond O, C double bond O. Three C double bonds O are there. We have to consider this double bond as a single bond. Okay, or sometimes if a triple bond is there, double bond is there, or triple bond is there, and then we have to consider that one as a super pair, and ultimately we have to consider those double bonds as a single bond. That is the meaning of this fifth postulate. And the last one is the suppose a molecule which is showing the resonance, and to each of the resonating structure it is possible to apply the VSEPR theory. Means each resonating structure will obey the VSEPR theory postulates. That is the meaning of this fifth postulate. This is regarding the VSEPR theory and its postulates. We have discussed all. And as I said earlier, there is a repulsion between the electrons. Okay, and here we are going to identify the two types of electron pairs. First one is the lone pair